In the recent game industry, where the volume of content required is increasing with the evolution of hardware, the time has come when the use of AI models is indispensable for the automatic generation of in-game objects and the balance adjustment in level design. The ideal state of AI models in the game industry was one of the important agenda items at the 36th annual meeting of the Japanese Society for Artificial Intelligence held from June 14 to June 17. This time, we covered a session called Agent, Game AI from the same tournament, which was held as a hybrid due to the influence of the new coronavirus. Mechanism that FF15 friends support the hero. The game AI that forms the game content is character AI to move the characters, meta AI to dynamically control the flow of the entire game, and partial AI to support spatial recognition. It is roughly classified into three types. As a new AI model that links these, Yoichiro Miyake of Square Enix has proposed the MC's AI Dynamic Cooperative Model, Meta-Character Spatial AI Dynamic Cooperative Model. The behavior and effectiveness of the MC's AI Dynamic Collaboration Model is determined by which of the three AIs is the starting point, what messaging is exchanged, and in what order they are launched. In this presentation, we talked about some design patterns expected in this MC's AI Dynamic Cooperation Model. For example, if you want to create a situation where fellow NPCs rush to recover players as needed during in-game battles, you need to optimize who behaves and how. In the MC's AI Dynamic Collaboration Model, the NPC character AI first applies for permission to help the player against the meta AI. The meta AI will then instruct the partial AI to search for a character that has the shortest distance to the player and is not in combat. Next, order the NPC selected from the search results to recover the player, and specify the script to let the other NPCs continue the battle and at the same time speak the dialogue according to the scene. During this time, the character AI that became the recovery role asks the partial AI to search for the path from the current position to the player, and moves and recovers based on the result. In addition, if you want to create a situation where a fellow NPC leads the player's destination, the fellow NPC must anticipate the player's intention and act accordingly. In these cases, the meta AI will estimate the player's destination, ask the partial AI to search for a path, and request a point in front of the player and at an appropriate distance from the path. At this time, the partial AI returns the optimal solution to the meta AI using a technique called tactical position search. When the move command is transmitted from the meta AI to the character AI requests the partial AI to search for a path to the destination. The mechanism is that the character actually moves according to the search results. By repeating this series of exchanges at regular intervals, it is possible to realize an NPC that leads the player. Miyake says that such a mechanism has the potential to function not only in the game industry but also in the realization of digital twins and metaverses that imitate the real world, and eventually as the cornerstone of the smart city concept. Players grow character AI. Square Enix's Border Gautier introduced Wonder, the character AI decision-making system used in the company's tech demo. Wonder is a tech demo for verifying the process of character AI growth by allowing players to evaluate the actions that character AI selects for smart objects in virtual space. It was also used in the company's machine learning and emotional expression sessions at GDC 2022. A smart object is a general set of preset items that contain a variety of information about an object, such as size, weight, and shape. Based on these parameters, a list of actions that can be performed is generated. Wonder's character AI learns while evaluating its own actions by being praised or scolded by the player from a state where it does not know the proper use of each item at all. Also, the action for similar items is that knowledge can be inherited by comparing shapes and holding styles. The techniques of Goal Manager and GOAP, Goal-Oriented Action Planning, are used to make decisions on character AI in this process. Goal Manager is a utility-based system that manages actions such as singing, eating, and drawing. The target action is determined based on the score calculated here, and GOPE, which will be described later, plans the process. As the name implies, GOPE is a technology that plans actions by going back from the purpose to the current state. For example, for the goal of satisfying hunger, plan actions to calculate back from the final goal, such as eat pudding, make pudding for that, and learn a recipe for that. In the game industry, it is mainly used for AI of enemy characters in the battle scene. Wonder has further expanded GOPE to verify the growth of character AI. Each action of Wonder has a dynamic cost calculation function based on the current psychological state and physical condition of the character AI, and if there are multiple plans, the plan with the lowest execution cost to achieve the purpose is designed to be selected. For example, when you are in a state of I like pudding or I have a pain in my leg, the three actions for making and eating pudding mentioned above for the goal of satisfying hunger and going to get an apple and eating, suppose there are two plans consisting of two actions. At this time, because I like pudding, the cost of the action of eating pudding is low, and because the leg hurts, the cost of the action of going to get an apple is calculated high. As a result, the plan of making and eating pudding, which has a large number of actions but a low total cost, is selected. Toward a balance between deep reinforcement learning and entertainment. In recent years, due to the rapid development of deep learning, there are increasing cases where AI models surpass humans in highly competitive video games such as Go and Shogi, as well as Dota 2 and StarCraft. On the other hand, there are few examples of deep reinforcement learning being used to develop character AI in the game industry. This is because the behavior of the agent must be implemented according to the specifications of the game planner in order to be established as traditional entertainment. Therefore, Mr. Joji, a graduate student at Rikyo University, proposed agent reinforcement learning using a state machine with a deep neural network. The idea is to control the final agent behavior as requested by the planner by dividing and incorporating deep reinforcement learning into conventional character AI construction methods, such as rule-based, state-based, and behavior-based. So far, several researchers and game developers have published previous research. In this technical verification, we are trying to control the agent by operating while switching between multiple deep neural networks divided for each state. Using a 3D model created with Unity 3D, in a two-dimensional space consisting of a passage on the left side and a hall on the right side, take a ball that appears at a random position in the right side area and move from that position to the passage entrance in the left side area. An agent who learned a task consisting of 4 states, going through the passage to reach the goal point and running backward from the goal point and returning to the entrance of the passage was shown. As a result of verification, the learning time could be reduced compared to the case where a series of tasks were trained only by deep learning without dividing as a state machine, and the situation where tasks were required to be completed in a specific order. It means that we were able to demonstrate that excellent performance can be obtained in the future. He wanted to consider building a model that can learn while transitioning between multiple deep neural networks by controlling the learning process for each state machine.